next thing we're going to talk about is linear equations and the graphs of lines. I know we've already talked about quadratics, so this kind of seems like a little bit of a back step, but I want to most specifically talk about graphs of lines. So a linear equation in two variables can be written in standard form, which is ax plus by equals c, where a, b, and c are any real number and a and b are both not zero, right? I can't have them both be zero because then I wouldn't have any x variables or any y variables. It's also important to note that the graph of a linear equation is a straight line, and every point on the line is said to satisfy the equation, so it's part of the solution set. When we have a line, a straight line, a linear equation, we can calculate the slope. And the slope is our change in y over our change in x. Some people say that's the rise over run, vertical change over the horizontal change. So in order to calculate the slope, I take my difference in y divided by my difference in x. One thing that's really neat about linear equations is if I take them from standard form and I solve for y, that puts me in slope-intercept form. And when I convert a line to slope-intercept form, I already know two really important things. I know my slope and I know my y-intercept. And using this information, I can graph or visualize my line. So here I have 2x, let me write that in a better color, plus 3y equals 4, negative 4. And if I go ahead and solve for y, I'm going to get an equation in slope-intercept form. I have y equals negative 2/3 x minus 4/3. So then in this case, my slope is negative 2/3, and where my graph crosses the y-axis is at negative 4/3. There are four different types of slope. There's positive slope that looks like it's going uphill. There's negative slope that looks like it's going downhill. There's horizontal slope, and then there's vertical slope. Now, vertical slope, that's going to be a line that looks like x equals some constant, right? And its slope is undefined. Now, one other thing that's undefined in mathematics is dividing by 0, right? So let's say this is the line x equals 4. So I've got this point, this is when x is 4, y is negative 1, and this is when x is 4, y is 1. And let's say I had to calculate the slope. Well, remember, slope is my change in y over my change in x. So I could take 1 minus negative 1 over 4 minus 4. Because x is constant, right, it doesn't change, my denominator when working with vertical lines is always going to be 0. We can't divide by 0, so the slope is undefined. Any equation set x equal to some constant is going to have a graph that's a vertical line and it will have undefined slope. Any equation of the form y equals b is going to be a horizontal line, and we'll say that says 0 slope. So let's take a look at this. I've got when x is 3, y is 5, and when x is negative 2, y is 5, and let's see why that slope is 0. So I'm going to take my change in y, which doesn't change, over my change in x. That gives me 0 over negative 5, which is just 0. So we say it has a slope of 0. We can use the slope to graph lines. So what we can do is we can determine our slope, graph the y-intercept, and then use our slope to determine where the next point is. Then we connect those 2 points. Why do we connect those 2 points? Well, let's say I have 1 point. How many lines can I draw through that point? I have infinitely many different lines I could draw through that point. But if I have 2 points and I want to connect them with a straight line, there's only one possible line I could draw through those 2 points. So minimum to graph a line, you need to find at least 2 points. So why don't we go ahead and try graphing these linear equations. So the first thing I need to do is sketch a coordinate plane.
as best as I can. All right, so let's go ahead and graph our first line in blue. So I know my y-intercept is -3, and my slope is 4, but I'm going to write that as a fraction as 4 over 1, because remember our slope is rise over run. So I'm going to go ahead and go up 4, 1, 2, 3, 4, over 1. That helps me find the next point on my line. I can continue this pattern. I could go up 1, 2, 3, 4, and over 1 to find the second line, another point on my line. So here is the line y equals 4x minus 3. Now in green, I'm going to go ahead and draw our second line, which is y equals -2/3 x plus 4. So my y-intercept is a positive 4. So this is when x is 0, y is 4. My slope is -2/3. So this is going to look like it's going downhill. So I'm going to go down 2 over 3, down 2 over 3. So here's the equation for the line. So here's the graph of the line, y equals -2/3 x plus 4. Now, I don't have to be given the equation of a line in order to graph the line. I can just be given the slope and a point on the line, and I will know what the graph of this line looks like. Okay, so I'm going to go ahead and take, for number 1 in blue, I have a graph of a line with a slope of 2/3, so that's going to be a positive slope, and a y-intercept of -4. So when x is 0, y is -4. Here's my y-intercept. With a slope of 2/3, I'm going to go up 2, that's my rise, and then over 3, that's my run. So here's the point. I go up 2 over 3. So here's the graph of this line, which would be the line y equals 2/3, because that's my slope, x plus my y-intercept, which is -4. Now, for this next equation, I'm not going to know how to find the equation of the line just yet. We'll get to that, because I'm not given the y-intercept. I'm just given a point on the line. So we're going to graph this in green. So I have the point when x is 3, y is 1. So here's where x is 3, y is 1. And I have a slope of -4. So that means before I go down, I go over 1. So I'm going to go down 1, 2, 3, 4. 1, 2, 3, 4, and over 1. So this is the point on my line. And there we go. So we're going to talk in the next couple slides about how to find the equation for this line. But the first thing I want to introduce is the concept of parallel lines. So parallel lines have the same slope. It could be positive slope, they could both have the same negative slope, zero slope, or undefined slope. And because they're parallel, they're never going to intersect, fun fact, but they have the same slope. So if I'm given the equation of a line, y equals -1/2 x minus 6, I know that its slope is -1/2. And if I'm given the line 2x minus 4, y equals 3, I need to put this line in slope-intercept form in order to determine if they're parallel. So I'm going to take 2x from both sides. That gives me -4y equals -2x plus 3. I gotta go ahead and divide both sides by -4. I get y equals 1/2 x minus 3/4. So this has a slope of 1/2. Do these two lines have the same slope? No, I've got -1/2 and +1/2. So these are not parallel. The next type of line I want to talk about are perpendicular lines. So two lines are perpendicular if they intersect at a 90-degree angle, okay? When two lines are perpendicular, the product, so if I multiply their slopes together, it's going to be -1. It's also important to note that if I have a horizontal line or a vertical line and a horizontal line, they're always going to intersect at a perpendicular angle. But the product of their slopes can't be -1 because you can't multiply by undefined, which is the slope of a vertical line. So in order to determine if the following lines are perpendicular, I want to go ahead and get this in slope-intercept form and see if the product of their slopes is -1. So I'm going to go ahead and subtract 2x from both sides. I get 3y equals -2x plus 6. I go ahead and divide both sides by 3. Y equals -2/3 x plus 2. I have a slope of -2/3 and a slope of 3/2. If I multiply those together, I get -6/6, which is 1. So why don't we go ahead and find a few more perpendicular slopes. So let's find some slope and then some perpendicular slopes to those lines. So if I have a line with a slope of 1, the slope of the line perpendicular to it would be -1, because -1 times -1 is -1. If I have a slope of -4, what would I want to multiply -4 by to get a -1? Well, sometimes this is called the negative reciprocal. So I'm going to take the reciprocal of -4, which would be -1/4. But I need to take the negative of that, which gives me a +1/4. And -4 times 1/4 is -1. If I have 5/8, I'm going to multiply by that -8/5. See, I took the negative reciprocal. 5/8 times -8/5 is going to give me -40 over a +40, which is just -1. So that's an example of how I would find some perpendicular slopes. The next thing I want to talk about is using the point-slope form of the equation for a line. So the point-slope form of the equation of a non-vertical, that's a key point, right? It can't have undefined slope like a vertical line would. The equation for that line, given a slope and a point, is y minus y1 equals m times x minus x1. And this is an equation you're going to have to memorize. So, for example, what if I want to write the point-slope form of the equation of the line with slope -1/2 that passes through the point 5, 2. So 5 is my x1 and 2 is my y1. So I've got y minus 2 equals -1/2 times x minus 5. So I get y minus 2 equals -1/2 x plus 5/2. I'm going to add 2 to both sides. So I get y equals -1/2 x plus 5/2 plus 2. Now I need to add these two constants. So I'd write 2 as a fraction over 1. And remember that any number multiplied by 1 is just itself. So I'm going to harness the power of 1 to make these two fractions have the same common denominator. So I'm going to multiply our constant by 2 over 2. That gives me y equals -1/2 x plus 5/2 plus 4/2. So our final answer is y equals -1/2 x plus 9/2. Let's do a few more examples. So next, I'm not given a point and a slope, I'm given 2 points. So what I'm going to have to do first is calculate the slope. So remember, our equation for slope is my change in y over my change in x. So let's go ahead and find our slope. I'm going to take -7 minus 3 over 5 minus a -4. That's going to give me -10/9. Now that's not a very fun slope to work with, but we're gonna conquer. So I've got y minus y1 equals m times x minus x1. So it doesn't matter which of these points I pick to substitute into my point slope form, I'll get the same answer. So I'm going to pick this for y1 and this for x1 and this for y1. So I've got y minus 3 equals -10/9 times x minus a -4. Y minus 3 equals -10/9 x minus 40/9. I'm going to add 3 to both sides. Well, remember 3 is the same as 27 over 9 because we need this to have a denominator of 9, so I'm going to add 27 ninths because they're equivalent. So I get y, I'll write it right here. I get y equals negative 10 ninths x minus 13 ninths as our final answer. Next, what if I want to find the equation of a line through the point when x is negative 3, y is negative 6, that's perpendicular to 2x plus 3y equals 6? So first thing I need to do is determine the slope of this line. I'm going to subtract 2x from both sides. 3y equals negative 2x plus 6. I divide both sides by 3. Y equals negative 2/3 x plus 2. Awesome. So the slope of this line is 2/3, but I want to find the equation of a line through this point that's perpendicular to negative 2/3. So what do I multiply negative 2/3 by to get negative 1? Well, that's going to be 3/2. So that's going to be my slope, so that my line is perpendicular to this line and goes through the point 3, 6. So this is going to be perpendicular to this and go through this point. So I got y minus y1 equals m times x minus x1. Y minus a negative 6 equals 3/2 times x minus a negative 3. Y plus 6 equals 3/2 x plus 3. I have to distribute. Y plus 6 equals 3/2 x plus 9/2. Cool. If I go ahead and subtract 6 from both sides, 6 is 12/2. So I'm going to subtract 12/2. That means I have y equals 3/2 x minus 3/2. So there are some examples of how we can find the equation of a line. Keep in mind you're not always given your slope. Sometimes you'll have to calculate it. Sometimes you'll have to find it. But it may not always be given to you.